Hey gang, at Real Creative, we help companies with game-changing technologies tell their story. And today we have one I think you're really going to like. They are probably one of the most talked about companies on the OTC. They're up over 500% this year, and they just became a fully reporting company with the SEC. Today, I want to introduce you to American Fusion, ticker AMFN. And with us is Brent Nelson, the executive chairman of American Fusion. Brent, welcome. Welcome today. In a recent press release, you said the Texatron Fusion Engine works. Could you be the first company with an actual working fusion reactor? And what does works mean?
Okay, well, Scott, I'm going to correct you. Thanks for having me on, but I'm going to correct you. And it's we're not calling it a fusion reactor anymore because people relate the word reactor with radioactivity. And I was in DC last week, and if you talk fusion reactor, everybody goes, everybody's worried about the radioactivity it generates in the radioactive waste. So we're calling it a fusion engine now because that's really what it is. It kind of works like a diesel motor. So, with our pulse fusion technology, what happens is by pulsing the fusion several times a second, you create, it's almost like a diesel engine. So it kind of gets itself going. And once it gets going, it keeps running as long as it's got fuel. So, when I say it works, we spent over 10 years, 9 years in our laboratory, here in Texas. And I think what you're going to see is the culmination of 40 years of development from Dr. Brandenburg. So it's his life's work. And, over the last 9 years, we've developed it into not only a working prototype, but now we're building our first, we're going to call it a showcase pre-production model.
Okay, could you, for people that don't understand, they hear great understanding of the reactor, why you've taken that word out, but can you explain what aneutronic fusion is, Texatron aneutronic fusion is, and how it is different than nuclear? Tell us why it's cheaper, safer, and less regulations.
Okay, so when we say that, the nuclear energy boom is on in the United States, everybody is talking about a fission reactor. And a fission reactor creates radioactive water, basically radioactive waste. And, that waste has to go somewhere. And at the end of the day, it's going to sit somewhere for 100,000 or 150,000 years and it's contaminated. So what it has to do is sit in a bunker somewhere inside a mountain or, be surrounded by concrete. And it just sits there, the radioactive waste. What we have is an aneutronic fusion engine. And by saying aneutronic, it means it's non-radioactive. So our two fuels, deuterium and helium-3, the reaction, when they fuse together, it creates helium-4. So by creating helium-4, everybody knows helium-4 goes into a balloon at a birthday or Mother's Day. It creates, lighter than air phenomenon. So anyway, that's what we create. There may be a few extra neutrons that create just because of the excitement inside the chamber, but it's all confined by radio or by a magnetic confinement system.
Deuterium and helium-3. Deuterium is seawater. Helium-3 is really difficult to come by. In fact, they're trying to go to the moon for it. How do you get it? You mentioned a few weeks ago about a potential supply agreement. Can you go into a little more detail on that?
Okay, so we're negotiating a supply agreement right now with maybe the world's largest harvester of helium-3. And so we can't disclose the company name yet, but we're looking for a 10 to 14 year agreement. We've asked for 14 years, which will take us to 2040. And so we've sent them our requirements, and we've been negotiating for 3 months now. So when people say there's no helium-3, the what I say is you just need to know where to look for it. And so there's lots on the moon. There's lots here on Earth that's being created every single day. And maybe not lots. It's still, it's an expensive commodity only because, the harvesting sequence is expensive.
Okay, let's take the 5 megawatt Texatron. How much helium-3 would you need in that, and how much ballpark would it cost? Ballpark.
Well, it depends. It'll depend on our final contract agreement, right? So the cost, it's like I said to the folks with the helium-3, if we're going to get fusion energy running in this country or running on the planet, we're going to have to create more helium-3. And really, it's really only for our system. Most fusion reactors are deuterium-deuterium or deuterium-tritium, and that's radioactive. And tritium, radioactivity inside any kind of a reactor is hard on equipment, and it wears out and everything else. So what we're talking about is we're trying to take the price of helium-3, and I use the analogy of taking it from the price of an airplane and bringing it down to the price of a pizza. So we've actually offered to partner with this group and to harvest more if we can, and to bring the price down.
Okay, so now you've built several prototypes, Texatron prototypes. You're up to version 9 now, is 0.5 megawatts. Now, did you achieve net energy or fusion with that?
Okay, the problem with our testing regime is that it wasn't internationally recognized, so we can't say that.
Okay.
But what we will do is in the 5 megawatt model, which we were looking at the fabricator the other day with Dr. Brandenburg. And Dr. Brandenburg said that the mainframe came out so well, it just needs to be final machined, and the electrical inputs, outputs have to be attached. And so that's being done now. And Dr. Brandenburg believes that we will make fusion inside the 5 megawatt Texatron by the end of the summer. So if we can achieve that, and we'll have 5 PhDs standing around with their clipboards, and we'll have we're trying to acquire a whole bunch of international testing equipment that people believe, and so those measurements will be taken. They can do peer review stuff. We can create some reports on that, and then as they are finished, we'll publish them. And we're very confident that by the end of the summer.
What data did you see? What data did you see, or what did you get that would say, let's scale this up 10x? Was it ion temp, density, confinement time, pulse energy output? What was it that really said, hey, we can scale this thing?
Well, the answer is yes, right? So, we've over the last 9 years, we've actually developed 9 prototypes. So the 5 megawatt pre-production model that we're calling the Fusion Engine, 5 megawatt Texatron that we're building is actually number 10. So we don't know whether to call it number 1 pre-production or number 10, unit. So anyway, it's our 10th iteration of the Texatron. And so, literally I've witnessed, in the vacuum chamber, over my shoulder here, I've witnessed literally thousands of magnetic confinement experiments. And when I say thousands, it's probably in the tens of thousands, over the last 10 years, And so what we've done is the hard part was really creating the magnetic confinement, the coil that holds everything inside. What we need to do is we need to retest the plasma density. We need to retest the plasma temperature. We need to retest the output on the, that the shock wave, I'll call it a shock wave, the pulse wave creates. And then actually after that, then we're going to kind of finalize our equipment, really to harvest that energy and to make it commercial.
Okay, so you're going to bring in equipment, PhDs, but equipment to validate the output of the 5 megawatt. Is there like an organization or literature or a machine that says you've done it? Is there what certifies results that you have achieved net energy? What would that be?
Okay, so the testing equipment is actually quite expensive, right? So, what we're doing now is putting together a regime of testing, which we will have certain, I'll call them fusion experts, look at before we actually do our initial test. We want to make sure there's not a doubt, and
Okay.
everything will be filmed and recorded, and all that information will be, I guess, made public when we're ready.
Can you give us a ballpark time frame on when the fusion experts could look at it first? Not when you're going to show
Okay.
it, but when the fusion experts would see it.
Our Dr. Brandenburg said earlier this week when he saw the shape of the mainframe, it's so close to being done. He said he's actually moving our time schedule up by about 3 months. We thought by the end of the year, but Dr. Brandenburg is saying by the end of the summer. So let's see.
Okay. Do you need to have like a certification in order to sell power? Is there some group that says you have to have it achieve such and such in order for you to sell power?
Right. So yeah. So not really to sell power, but to operate in Texas, for instance, which is a licensed state. We need to have their certification. We made our application. I actually saw a copy of it on the internet yesterday that somebody found, which was made on, I think it was February 26th. And it's the Department of State Health Services, which is in charge of all radioactive activity in the state of Texas. So we've already had 2 rounds of comments from them, and we hope that we're near the end of certification.
Okay. So several press releases have stated non-dilutive funding. You want non-dilutive funding. You don't want to dilute shareholders. The Texas grant, or could Texas give you a grant? Department of Energy, give us insight on those 2 possibilities.
Okay, so we are talking to several government agencies, including in Texas, and they're putting together some applications right now for a new grant in Texas, which is going to be applied for, I think in the next few weeks. So whether we get grant funding, as long as there is no IP that needs to go to the other side. When you do a government grant, very often they want a 10-year license for your technology, and we're just not interested in that. So if we can do it on our own, we're going to do it on our own. And so we're already dealing with some of the major data center builders. And so what we're doing is we want to fund really based on power purchase agreements, PPAs. So once we get our first PPA, we can. It's basically a bankable instrument. We can go to the bank and get the money. And simple as that.
Okay. See, NVIDIA, Gates, Amazon, Microsoft, Google, they're all funding these fusion companies that all have multi-billion-dollar valuations. By the way, Apple and Meta have not done anything yet. Are you talking to any of these companies at all now?
The answer is yes. And so we are talking already with at least some of those companies that you just mentioned. And, we've been approached by a lot of private equity groups that are developing other data centers in the country. I think what they figured out is that, having gas turbines create the electricity from now till the end of time isn't going to work. So what we're doing is we would replace that kind of technology over time.
You mean Mr. Musk talking about gas turbines?
No, a lot of the data centers are using gas turbines. So, I mean, some of these data centers are using a lot of power. So, we're looking at a couple of examples now, and we're talking to the powers that be, and we're going to see if we can move it to a power purchase agreement. So let's see how that goes.
Okay. Musk said, why do we need fusion when we have enough power from the sun? And I'd love to see how you would respond. I'm thinking, what do we need power locally if we have everything in the cloud? You're going to need power locally. You're going to need literally power locally. Give me your how you would say to Mr. Musk, the sun is not going to, you can't put the sun next to a data center, move it around.
Well, it's like geothermal energy. Geothermal energy would be a fantastic thing, except you can't move it, So, the sun is the same. For instance, a couple of weeks ago, I was up near the North Pole. A mining company flew me up there, and they're looking for, 12 megawatts of power. So we come up with a number, 20 megawatts, and they can take the power, and if they have excess power, they can sell it to the community and actually make a profit to, kind of supplement their costs. So at the end of the day, why are they looking at us? Because they were also looking at solar. But the problem with solar is, one, it only works 50% of the time or thereabouts. And up in the Arctic, for instance, sure, it can work 24 hours a day in the summer, but in the winter, it doesn't work. Yeah. There is no sun. So, so what we are is we're a 24/7, 365 power source that will be able to power remote locations. For instance, we've had other discussions about putting Texatrons to power parts of the Golden Dome up near the, past the Arctic Circle. Let's just say that. So we're already looking at several applications. I was in DC, last week, I think. I'm losing track of my weeks, but last week, and we talked to every branch of the military, and every branch is interested in what we're doing. So is the Department of War. So let's see how things progress. I mean, we're at early stages, but it's like we were having a meeting the other day, and we were talking to the sales guys, and basically once we put one unit out there, the sales guys become an order taker. So hopefully
so let's walk us through first revenue. Would it be a company funding to build a Texatron, a power purchase agreement, or something else?
Well, whether it's we think we have probably enough money to get the 5 megawatt unit going now, and that's all equity at this point, and so we think we're close to maybe 2 or 3 power purchase agreements. So whether it's a power purchase agreement, we're also in discussions with several family offices, for a hybrid equity / power purchase agreement type financing. So anyway, let's see what happens. We could also do a deal with, one of the big 7 guys. We're talking to them. So anyway, let's see which one falls first.
Okay, so let's do a hypothetical on let's say a 10 megawatt Texatron, which would be enough to power a data center. How much would it cost to build and fuel it, ballpark? How much cost to run? How much revenue could it generate each year? The margins, and then how long before that revenue and net would make it fully paid for?
When you say 10 megawatts, that would be a pretty small data center. Why don't we go to 100 megawatt unit? Okay. And so
what could 100 megawatt power? Would that be a city? Would that be a data center? What would that power?
Yeah, well, let's just say that some data centers out in Abilene, Texas, just one building, is 350 to 700 megawatts, right? So
okay.
Those are large data centers. So, I mean, what we're doing, what I'm trying to do is create a unit for the industry, and let's call it 100 megawatt unit. Okay. And based on a 100 megawatt unit, depending on the pricing of, based on location, based on, the application, based on which state it is, because, each state has different taxes and everything else. So each state is going to be a different number, so if you want to take a number, which we've analyzed, call it 6.25 cents a kilowatt hour, okay, for just making power, etc. That would generate $54 million a year. Okay, $4 million. And based on our calculations, it looks like it would be around an 80% EBITDA.
So, how much does it cost to build that? How much would it cost to build and
well, I'm not talking about how much to build it, but probably $12.5 million.
Okay. Margins
and
are
it's
80%.
Not very big. And the footprint of a 100 megawatt unit is it's 2.3 meters in diameter. So to give you an idea of size. So I mean, what we joke about is you can get a 30 megawatt unit into the back of a pickup truck. So think about that.
So this thing pays for itself within 1 quarter. It would pay for itself within 1 quarter. It would pay for itself within 1 quarter. And is that right? 2 quarters?
Maybe two. Yeah.
Wow. Okay. Now, I know the funding with what you guys have. I can't imagine you can build a bunch of these things. So do you see a company paying up front a premium to get access to the first one? Or maybe we want ours, we want it?
Well, the answer is maybe, because the answer is maybe because that's part of our sales pitch, right? If you want one and you want to sign up now, you'll be in the front of the line before the next guy. So if all of a sudden we have a big customer come to us and say, okay, we need 100 megawatt units, then we say, okay, the next person in line goes behind them. So when I say 100 megawatts, it could be 520 megawatts. It could be 10 megawatts. So what we're trying to do is create a system of measurement, as a guideline for the industry. And so at 100 megawatts, that's a nice round number. Everybody understands it. And, people can say, okay, I want a 0.1 megawatt, 0.1 unit size, which would be a 10 megawatt.
Okay. What in your gut, what do you think would be what industry is most likely the first customer?
Probably it's either data centers, mining companies, or remote locations. And those are 3 groups of customers we're already talking to.
The renewable energy facilities, solar, wind, could Texatron max out the capability of existing DC conversion infrastructure at those locations? Could that be a low-hanging fruit, or would that be too difficult?
Okay, so if you talk about renewable energy, we developed the Texas for an interstellar spacecraft. So now the other development was, 4 or 5 years ago, it was developed to be plugged into the infrastructure of a solar or wind farm. And so that's how it was created. So we didn't want to reinvent the wheel. We wanted to use existing infrastructure so that we could just plug it in. But going to a utility, you have a whole bunch of new regulations, and it takes time, it takes money, we'd prefer to go behind the meter where we can go tomorrow and start making power.
Go local. That's a lot easier with less red tape. Okay,
something that goes small. They want to go big, we go small.
Get it? Okay. If people are still listening, you guys probably aren't aware of this, but this company has a chip that they're building as well. Can you give us an idea of the chip that you have? Is it based on Texatron? Does it need Texatron to prove net energy? Give us insight on the chip, because I think people are going to be blown away by this chip as well.
Okay, the chip is really in its infancy, as far as development, but it's what we're calling a self-powered chip. So it basically uses another technology, not Texatron. We're still in patent development, so I can't really talk about it. And so that chip should be able to be self-powered. So it's like a self-powered chip that everybody else is
But
trying to get these
you're
days.
eliminating a battery. You're basically eliminating batteries with that?
Right, right.
Okay. That's based on something else that's not Texatron related.
It's a completely different technology.
Is it under the American Fusion umbrella?
Yes, it is.
Okay. In the last couple PRs, a lot of language in discussions we presented to when or what do these people need to see to write a check?
Well, first you have to believe in the technology. Once you believe in the technology, it's the future. And as far as we're concerned, we believe that the future is fusion and it's aneutronic fusion. We think that our competitors in the power industry are all going kind of a different direction. They think big, we think small. So, you're talking about, we were talking about a Westinghouse 1.2 gigawatt reactor, which is fission energy, and it's not a small mobile reactor, an SMR. It's a large, 3 Mile Island type deal. It employs several hundred or thousands of people, and creates radioactivity for over 100,000, or radioactive waste that has to be stored for 100,000 years or more. So, what we believe is the Kepler Fusion Engine is just the way I think the market's going to go. So by being first to market, we think that we can kind of control the market going forward. And if we do a good job, or even not a good job, we should be able to maintain a 50% market share, even if we don't do a good job. It's like the first Xerox or the first Kleenex.
Okay. You looking to uplist to OTCQB. When do you think that could happen?
The filing's already been made, so I'm not sure how long it's going to take. Everything else we're doing is regulatory, right? So the QB exchange, I was told yesterday it might be a couple of weeks, it might be a month. So anyway, it's going to depend on, I think it's FINRA and then the OTC. So anyway, they're looking at it, they're asking questions, and we'll respond to that as they come in.
Okay, now I think everyone on this call wants to know when we can get on to NASDAQ, because that's where the big money is. Are you going to need to change the preferred share structure in order to A, to get up to NASDAQ, and then B, to get institutional money?
No, the answer there is I don't think so. We're already talking to the Texas Stock Exchange, and the Texas Stock Exchange is going live in July of this year. And so in their words, they want us to be ringing the bell in the Texas Stock Exchange. So if we have our druthers, we'd rather be on the Texas Stock Exchange other than NASDAQ, even though NASDAQ is a high tech, is the technology stock exchange. So at this time, we're not really having any pushback as far as the preferred share goes. We may have to restructure the company to meet listing requirements. That's okay. That's an easy move. And we already have somebody that'll sponsor us. So we're, we're firing on all cylinders on our end.
Good. With it looks like finally the financial sites are now starting to show the correct number of shares out. And I think roughly 1.6 billion. Your market cap is a ballpark, about $200 million. So congrats on that, because a lot of people will look at the valuation before. What is your biggest fear with the company right now?
I really don't have any fears with the company. As far as, it's kind of a step by step. I think when we first got into this, we were looking at several SPACs. And the way the SPACs were working, they pulled all their money out, and the owners of the SPAC money, got a carried interest really for doing nothing, and it was about a $2 million legal bill to go with SPACs. So what we're doing is a little bit differently. We started OTC, and we've identified, I think it was 11 steps to kind of get onto a major exchange. So we're in that process now. Everything's going, knock on wood, everything's going just fine. And, let's see how it goes. We haven't seen any roadblocks at all. Everybody's accepting our technology, and when I think the world sees that our technology works, let's see what our valuation is. So.
Well, congrats, because you are really, as I said earlier, you are one of the most talked about companies on the OTC right now. Because if you can prove this, the world is your oyster. Give us an idea what investors should look for in the next 90 days.
I think we're gonna probably see. I'm hoping to have our first PPA in the first, within 90 days. So. We have a letter of intent out already to be signed for one, and we're talking to several different groups for PPAs, and so let's see one of those drops. That'll be a milestone. Our other milestone will be doing an agreement on the supply of our fuels and other things like that. But as far as development of the technology, everything that we're doing on our end, we don't see any delays whatsoever. We're hoping that as far as getting the parts and testing equipment, there won't be any long lead times needed, because that's the only thing that's going to slow us down. And so our certification, we're expecting that within the next 90 days as well, from the Department of State, Texas Health Services. So let's see what happens. I think once that all falls into place, and we're also going to be filing a bunch more patents, which is around another kind of we're creating another family of patents now. So that should be done too. Actually, as we speak, it's getting worked on now. So anyway, there's a lot of activity that the market will see over the next 90 days.
Give me a ballpark burn rate right now outside of the machinery. What's your ballpark burn rate per month?
It's maybe 100,000 a month. It's not very much. And so what we're doing is we're bringing in engineers, we're bringing in lab guys, we're bringing in, and as we bring in more folks, the burn rate's going to go up. But I'm a fairly frugal guy, so we run lean, we run mean, and just because one guy's an engineer doesn't mean he can't turn wrenches. So so we're multifaceted. We have a very diversified group of guys putting this together, guys and girls. So far so good.
Do you need someone maybe that's sits next to Dr. B? Just to have somebody there, just to have another person in the chair?
We already have two of those. So yeah.
Perfect.
So yeah.
Okay.
So
Brent, I want to thank you. I want to thank you. This is thank you for your time. This is very enlightening. I think more and more people, when they dig into this company, they realize that this is really a unique, very game changing. But if any more, for those looking for more information on American Fusion, links are below in the summary. We hope to be doing these probably once every quarter to give investors an update on how the company is progressing. Brent, thank you again. Thank you for this. This was a very good interview. Thank you.
Yeah, no, thanks, Ray.
Okay.
So thanks very much, Scott. Good to be here. And if you have any questions, reach out.